Let's review some key terminology from the logic section. Inductive reasoning, we're using patterns, we're making observations. Unlike deductive reasoning, we're using facts, definitions, properties, postulates, theorems. And we've studied two kinds of deductive reasoning that we'll look at in a bit, the law of detachment and the law of syllogism. When we use inductive reasoning and we explore patterns and make observations, we're going to make a conjecture about what's going to happen next, a guess. For example, we're looking at the pattern that every day I come to math class, my teacher asks me if I have a pencil. So I make a conjecture that next time I go to math class, my teacher's going to ask me for a pencil. But perhaps there's a counterexample. Yesterday, I went to math class. My teacher didn't ask me for a pencil. The counterexample is the specific case that proves the conjecture is incorrect. Or false. Remember the different ways that we can write statements. Negation. When we negate statements, we do it by putting in the not or taking out the not in the sentence. For example, I do not like to run. If we negate it, that becomes I like to run. We found the not in the sentence and we took it out to negate it. A conditional statement we usually write in the if-then form, such as if he runs, then he sweats. Using symbolic notation to simplify our sentence might look like R for run. If he runs, then he sweats, S for sweats. Then when we think of the converse, where it flips the conditional statement or writes it in reverse, we can start with the symbols and turn those around. S, then R. Now we still start our sentence with if, but now we're starting with the S part, the sweats. So if he sweats, then the conclusion, he runs. The inverse is another way to write a statement that takes the conditional statement and negates it. So using our symbolic notation, not R, then not S. We're negating the conditional statement. In words, what would that look like? If, now R was for running, so if he does not run, then he does not sweat. We didn't have not in the conditional sentence statement, so we include not when we're negating both parts. Notice though that it's in the same order. Now the contrapositive, the longest word, does the most things. We look at our conditional statement, we reverse it, so we start with the S, the converse, but we also negate it. So not S, then not R. So think of doing both things, flipping and negating. Flip and negate. Turn it around and deal with the nots. Put them in, take them out. So the conditional statement, we think of first flipping it around. So maybe we think of the converse. Look at how we wrote the converse. The S comes first, the sweats. So if he does not sweat, then he did not run. Sometimes you have to change the tense of the words to make it make sense. And then finally, the biconditional statement is when the conditional statement and the converse are both true. Then the sentence can go forwards or backwards. So in symbolic notation, where we'd see the conditional statement with R, arrow one way, and then S, because it can go both ways, our arrow goes both ways. So we want to think of it like a statement that can go both ways. In other words, the conditional and the converse are both true. For example, a polygon is a triangle if and only if it has 3 sides. And remember, you can abbreviate the if and only if, IFF. Now, why didn't I use the sentence up here, if he runs, then he sweats? Well, let's think about the converse. If he sweats, then he runs. Maybe he was doing something else that made him sweat. You really have to examine, can it be true both ways? A polygon is a triangle if and only if it has 3 sides. So if a polygon is a triangle, then it has 3 sides. If the polygon has 3 sides, then it's a triangle. Makes sense both ways. Symbolic notation is what we were using to simplify our statements and to see it a little bit easier. So let's remember all of the symbolic notation that we've studied. Our arrow, which is for when we want to say then, usually in an if-then scenario. Our double arrow, when we write the biconditional, that's our if and only if. Or remember the way to abbreviate it, IFF. Our triple dots, for when we want to conclude an argument when we say therefore. The pointy thing that looks like we're starting to write a capital A but we don't cross it, that's when we say and then upside down, that's when we say or. So being able to use these symbols can really simplify our statements and our arguments, so we have to write less. The Venn diagram helps us represent set relationships, meaning using pictures to show how something is a part of something else. Some helpful hints for Venn diagrams is that when we use the word all, we usually see a representative set inside another set. When we see the word some, or in an if-then statement, we use might, then it's a set overlapping with another set. Some people play tennis, some people play soccer, some people play both. I might play tennis, I might play soccer, I might play both. Then we have none or not or no, some sort of negative where the two circles don't intersect. Nobody that likes the Redskins also likes the Dallas Cowboys. And then when we say set, that's the groups that we're comparing. So it's the collection of objects, maybe the collection of numbers, or the groups that are being compared, such as the Redskins and the Cowboys in my previous example. Finally, the different types of laws we use in creating valid arguments. The law of detachment. Think of it usually as using one fact, versus the law of syllogism uses many facts, or at least more than one, to link a chain of events. Now, using symbols, the law of detachment looks like this. We're given a fact, such as P arrow Q, if P then Q. Someone states the hypothesis, and we can conclude with the conclusion. In words, that might look like, if I run, or let's go with, if he runs, then he sweats. That would be our P then Q. And then we're going to state a fact about somebody running. Joe ran. So how do we conclude? We say, therefore, Joe sweated. Because we're following the fact that if he runs, then he sweats. Now, the law of syllogism uses many facts and links a chain. So what does that look like with symbols? We start with a fact, maybe P arrow Q. We link it to another fact. So Q, where we left off, we pick up, leads to R. Maybe another fact, or as long as it's more than one fact linked up with another fact, then we take what was at the beginning and link to the end. The Q links up. So those can sort of cancel out in a way. So therefore what? P then R. So it's like you're telling a long story. For example, if he runs, then he sweats. And continuing with the story, well, if he sweats, then he showers. So concluding, or rather summarizing the story, is if he runs, ultimately what happens? Well, his sweating caused him to having to shower. So we could say, therefore, if he runs, then he showers, linking the beginning of our story to the very end of our story, kind of like giving a summary. Now, another law that helps us in making a valid argument is the law of the contrapositive, and that tags along with equivalent statements. Equivalent statements have the same truth value. They're either both true or both false. Which ones are equivalent? The converse and the inverse are equivalent to each other. The conditional statement and its contrapositive are equivalent to each other. So since the conditional statement and the contrapositive are equivalent to each other, then we can use the law of the contrapositive in any argument. How does that work? Well, first let's write that the law of the contrapositive is saying that the conditional and the contrapositive really have the same meaning. In symbols, what that looks like is if P then Q is a true statement, then I can conclude, so therefore, not Q, then not P is a true statement. This is the contrapositive of the original, therefore this must be true as well. Now, what does it look like using words? If he runs, then he sweats. If that's a true statement, I can conclude with, so anytime we make a conclusion, we say, therefore, if he did not sweat, then he did not run. And there you have your logic in a nutshell.